All right, so now that we've figured out how to identify and name the parent chain in an alkane, let's move on to the substituents. All right, so again, you have these, the whole shtick here is you're going to be given a molecule like this, and the first thing you're going to do is figure out what the parent chain is. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 contiguous carbons is my longest continuous set, so that's my parent chain. I know that this is going to be a decane. But now the question is, how do I identify all of these substituents? Okay, so I have 1, 2, 3 substituents. How do I name them? So again, we're going to use the same chart in order to figure out the name of your substituent, and the name is going to correspond to the number of carbons that are in that substituent. Okay, so for example, let's color code things here. This substituent here consists of just one single carbon, so this is a methyl substituent. Okay, notice that when it's a substituent, you replace the ANE with just a YL. All right, and at the end, we'll stick these at the beginning of our decane name, but right now we're just going to focus on the naming of the actual substituents. Okay, likewise, if I go to the top here, I have 1, 2 carbons in this substituent, so it is an ethyl. What about down here, my last one? What would that one be? Well, I have 1, 2, 3 carbons, so it is a propyl. Okay, so that's how you go through and you name your substituents. Again, you need the same set of prefixes. When we're talking about compounds that have rings involved, the ring could either be the parent or the substituent. It depends on how many carbons there are. The ring is going to be the parent chain if the number of carbons is greater than or equal to the number of carbons in the substituent. Okay, so in this case, this is the parent chain in this one is the cyclohexane because it has 6 carbons and the other group only has 1, 2, 3, making this a propyl group, and then a cyclohexane parent. But if we look on this other example here, 1, 2, 3, 4 carbons are going to be in this linear portion, the straight chain. So that's going to be my parent chain because there are only 1, 2, 3 carbons in the ring. So that makes it the substituent. So then if it's going to be a substituent, all you do the same as before, you're going to replace ANE with YL. So this is cyclopropyl. And then the parent chain would be the butane because there are 4 carbons. Okay, and again, how we go about constructing these together, that's going to be the last video. So right now, just focus on being able to actually name your substituents and name the parent chains. We'll figure out how to put these together when we get to the next video here. So there's another sort of layer of complication, which is when you have what are called branch substituents. Okay, so in this case, my parent chain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons long. So it's much longer than if I were to include this portion here. So that makes this my substituent. This has 1, 2, 3, 4, 5 carbons, but it is not a pentyl group, right? Remember, if it was a pentyl group, that would be as if this bond here was over here. That would be a pentyl group. But how do I go about naming it when it's branched like this? Okay, so you're going to start numbering your carbons. You kind of have to find like the parent chain within the substituent is kind of what's going to be going on here. But you're going to start numbering from the carbon that's attached to the parent chain. So in this case, 1, 2, 3, 4. And you're going to treat this as a group coming off of that chain. Okay, so again, 1, 2, 3, 4. So my root of my substituent is a butyl, and it has coming off of position 2 a methyl, right? A 1-carbon group. So this would be 2-methyl butyl. And when you have your substituents, when you have these branch substituents, you actually include all the names in parentheses. That's how it's going to be built into our, when we get to like actually putting these all together. So get in the habit of putting these branch substituents in parentheses, okay? So this would be a 2-methyl butyl substituent, all right? All right, so now there are some sort of special substituents that we have to know about, some special branched ones that have names that are not that sort of systematic names. They have common names associated with them. So first of all are going to be these groups with the iso prefix. All right, these are all groups that have sort of like forks at the end. So let me show you what I mean. So this 1, 2, 3 carbon fork would be an isopropyl group. All right, has this sort of like fork at the end. Notice that this one does as well, all the way at the end. This would be a 1, 2, 3, 4, 5 carbons. You're counting all of the carbons in that group when you're using the iso prefix, not just the longest contiguous set. So this is something that's a little bit weird about these common names. So this would be an isopental group. Okay, again, in this, I have this fork at the end, and this is 1, 2, 3, 4 carbons total. So this is an isobutyl group. Again, the signature of an iso group is having that fork at the end. And this is 1, 2, 3, 4, 5, 6 carbons. So this is an isohexyl group. And you can have an isoheptyl, isooctyl, isononyl, et cetera, right? As long as it just has that fork at the end and is otherwise a straight chain, it is an iso group. Okay? So there are a few more common ones. They tend to be small. We actually already know this one, but let's just go through all these various ones. These are the common ones that you're going to have to know. Come an exam, if you have a problem, you can use either the common name or what's called the systematic name for that branched group. I'll accept either one. To be honest, I wish everything was easier and we only stuck to the systematic naming scheme, but unfortunately, if you go to the back of the, the stockroom in the back, you would likely find isopropyl alcohol, not 2-propanol. So bottom line is these things are very commonly in use, and so we got to be able to recognize them when we see them. Okay, so if I had a 3-carbon group that was a straight chain, that would be a propyl group, right? So for example, this is just, I had some long parent chain here with 1, 2, 3 carbons coming off, it would be a propyl group. But then we learned that the isopropyl group is when it's 3 carbons and a fork at the end, okay? So this, again, the common name would be isopropyl, whereas the systematic or IUPAC name would be that 1-methyl ethyl, like what we learned as to, when we learned how to sort of generally name branched complexes, we would have arrived at 1-methyl ethyl, but again, this has been around for so long that it's commonly referred to as an isopropyl group. Okay, so what about 4-carbon groups? So again, if it's a straight chain, we would have referred to that as a butyl group. And then there are 3 different special 4-carbon groups that we want to pay attention to. So first of all, the one that we already went over is isobutyl. You can recognize iso because it's got that little fork at the end. The systematic name for that would have been 2-methylpropyl. Okay. Another one is sec-butyl. Again, there are 1, 2, 3, 4 carbons in the sec-butyl chain, but notice that it is not linear. It's actually 1, 2, the parent chain is bound to the second carbon. That's where that name comes from. All right, and the last one is a special group called a Tert Butyl group. So again, butyl just have 1, 2, 3, 4 carbons. Butyl is where all three, you have 3 methyl groups down to that same carbon. All right, so that's a big, bulky substituent group. And the last special group we're going to talk about is the 5 carbon groups. So if it was a straight chain, that substituent would be referred to as a pental substituent. We already learned if there are 5 carbons, but it has this fork at the end, that would be considered an isopentyl group. So it would have that common name. Again, 1, 2, 3, 4, 5 carbons. This is also referred to as an isoamyl group. Sometimes, I have no idea why, probably historical reasons. Isopentyl is fine with me. And then lastly, a neopentyl group. So this is the last special common name for a branch substituent that we're going to learn. So again, pentyl, so we have 1, 2, 3, 4, 5 carbons, but the neopentyl is referring to this big bulky group, very similar to a Tert Butyl group, except for now you have this carbon in the middle separating the parent from that big bulky group. Okay, so these are just these special common names that we have to know when we're naming our substituents. All right, so practice those, and then we can go to putting them all together to form the actual name of these alkanes.